Hello and welcome back to another video. So today I'm going to be reviewing the Cooler Master TD500 mesh, and hopefully you've seen the build I've put together and the full step-by-step build guide in the case. If you haven't, I'll put a link to them in the description so you can go ahead and check them out. So last year really was the year for mesh fronted high airflow focused cases, and last year I reviewed the Landcool 2 mesh, which was my case of the year, and the Purebase 500 DX, which was a very close runner-up. So I was really pleased to be able to get my hands on this case and test it out. So the Cooler Master TD500 mesh comes in 4 different versions. It's available in both black and white, and both with and without a controller. So going on to look at some of the case specs. This is a mid-torque case, weighing in at just under 7 kilograms. It will support motherboards all the way up to eATX. From a power supply point of view, its ATX power supply is up to a maximum length of 180 millimeters, although if you do remove the hard drive cage, that can be increased to 295 millimeters. For CPU cooler height, up to 165 millimeters are supported. Graphics cards, you can fit some pretty large graphics cards up to 410 millimeters. Looking at radiator support, you can fit a 360 millimeter radiator both at the front and at the top, while you can fit a 120 millimeter radiator at the rear. Importantly, a 280 millimeter radiator will only fit at the front. Looking at case fans, this case will accommodate a maximum of 7 120 millimeter case fans. That's 3 at the front, 3 at the top, and 1 at the rear. Alternatively, you can use 2 140 millimeter case fans both in the front and at the top, while at the rear you are limited to a 120 millimeter fan. The case comes with 3 addressable ARGB fans included. They're mounted at the front of the case, and Cooler Master have made it really easy for you to connect these up. The fans come with a 3-pin power connector, but Cooler Master have these all connected up to a triple fan splitter cable, so there's just one cable to plug into your motherboard to power the fans. It's a similar story with the ARGB. Cooler Master have included one of their triple ARGB splitter cables and have it pre-connected up to the fans. So you just need to plug the other end into an addressable header on your motherboard. If your motherboard doesn't have an addressable ARGB header, the version of the case that I got came with an ARGB controller. It's just a simple matter of plugging the end of that triple splitter cable into the controller and then plugging the other end into the SATA cable coming from your power supply. You can then use the button on the back of the controller to cycle through the ARGB effects on the case fans. Alternatively, you can use your case's reset button to control the ARGB effects by plugging the reset wire into the ARGB controller rather than into your motherboard. This is going to be particularly useful with the back panel on. If you don't want to remove it to change the ARGB effects, you can simply use the reset button to cycle through the different effects. Another nice feature that Cooler Master include with the fans in this case is that the bottom case fan is mounted with plastic pins rather than fan screws. And the reason for this is the front fans need to be screwed in from the inside of the case. And obviously with the power supply shroud bin there, you're going to struggle to screw in and unscrew the bottom fan. So the plastic pin mounting system makes mounting this bottom fan fairly straightforward. Importantly, if you don't like the idea of this mounting mechanism, you can of course use standard fan screws and just go to that little bit of extra effort to get them screwed in down at the bottom. I've got a right angle screwdriver which worked very well for doing this, and this was one of my criticisms of the NR200P with the fan mounting system at the top. It limited what you could do with it. Here you can use their mounting clips or you can use standard fan screws with a little bit more effort, so that's a nice feature. So as we've mentioned, mesh front panels with no dust filters below them have become fairly commonplace in the last year. What sets this case apart is that the design of the front panel extends onto the left side panel, and there's little notches in the tempered glass extending all the way over the panels, carrying that design from the front panel into the side of the case, and I think this looks absolutely stunning. Removing the side panels is fairly simple. The left side panel is held on with 2 captive thumb screws at the top. Once these have been loosened, the panel can simply be levered out and lifted away. The right side panel is held on with 2 captive thumb screws at the back. Once they have been loosened, the panel can simply be slid back and lifted away. The mesh front panel can simply be pulled away from the front, and as we've mentioned, there's no dust filter below it. On the top of the case, we've got a magnetic dust filter which can simply be lifted away. We've got a second dust filter at the bottom of the case, covering the cutout for the power supply's intake fan. And when you look at the build quality of the rest of the case, this dust filter is a little bit disappointing. It's really just a thin layer of mesh with quite an awkward mounting mechanism. There's no supporting material around the outside of the dust filter, there's no magnetic connection, and it really stands out like a sore thumb in a case which is otherwise quite well made. Looking at the front I/O, we've got two USB 3.2 Gen 1 Type A ports, we've got separate headphone and microphone jacks, there's a power button, a reset button, and hard drive indicator LED. Important to note, there's no USB Type-C on the front I/O. Moving inside the case, at the bottom there's a power supply stride with a cutout, so your power supply is going to be visible. On top of the power supply, there's the option to mount two 2.5-inch SSDs, and then just above that we've got 7 PCIe expansion slots. At the rear of the case there's a cutout for the power supply, but no detachable bracket for mounting it. Moving into the rear compartment, we can see there's plenty of cable tie points. The cutouts look to be in all the right places, and it's nice to see the Cooler Master included rubber grommets over the 3 main cutouts to the right hand side of the motherboard. Down at the bottom of the case we've got a hard drive cage which will accommodate either two 2.5-inch or 3.5-inch drives. Nice to see you do have the option of removing the hard drive cage, although only partially. The right wall of the hard drive cage is held on with 2 screws at the top and 2 screws at the bottom. Once they're removed, the right panel can simply be removed. This significantly increases the space at the bottom of the case for cables and will allow you to accommodate larger power supplies. I actually think it's an advantage only being able to remove one side of the hard drive cage, because it means that the left side acts as a bracket, keeping any cables in the bottom compartment behind the power supply shroud, and means they're not visible in the front of the case. There's also the option to mount a further two 2.5-inch drives on dedicated mounts in the rear of the case. I'm really a big fan of the mounting mechanism Cooler Master uses for these drives. You simply screw little metal pegs into the rear of the drives, push rubber grommets into the cutouts in the case, and then it's just a simple matter of pushing the drive into the rubber grommets, and that holds it in place. So although this case has cutouts allowing you to mount 4 drives using this method, 2 at the front and 2 at the rear, Cooler Master will include mounting accessories to allow you to mount 2 drives using this mechanism, although they do include screws allowing you to mount a further 2 2.5-inch drives using the hard drive cage. So that's all the case features. Let's have a look at the build I put together in the case.
I am on top of the world. I am on top of my life. And it is all 'cause of I am stronger than before. I'm not alone anymore. And it is all 'cause of
Okay, so this brings me on to some of the things I liked about the case. And I think the first and biggest thing I liked about the case is just how good it looks and the design choices that Cooler Master have made to achieve that. And I think that's largely due to the very distinctive front mesh panel, but Cooler Master didn't stop there. They continued that design onto the side panel with those very distinctive cutouts in the tempered glass panel. And I think that's what makes this case look so good. Normally when I'm filming a build, I have the side panel off, and that's because the lights I'm using are going to give a lot of reflection off the side panel and prevent you seeing what's inside. But actually when I was putting the build footage together, I wouldn't have done this case justice filming it just that way, and actually had to add a shot with the side panel on to show just how good it looks. So the other thing I liked about the case was to do with the front fans. You've got 3 good looking addressable RGB fans that come with a triple fan splitter cable and a triple ARGB splitter cable, so connecting them up is really straightforward. I like as well the fact that Cooler Master have included a controller with the case, and I like the option to connect that up to your reset button, so that you're not going to have to take the rear panel off every time you want to change the RGB effects. So you've got options there with that. As I mentioned, I'm a big fan of the SSD mounting mechanism that Cooler Master used in the case, and as well I really like how the hard drive cage removes, leaving the left wall in place. Some people may initially look at that and see it as a negative that the hard drive cage which only partially removes, but that wall is going to keep your cables out of view. And in other cases where the hard drive cage removes fully, it's really easy for those cables to spill over and be visible from the front of the case. So Cooler Master have done a great job with this. Moving on to build quality, this is very definitely a mixed bag in this case. From a build quality point of view, I didn't have any issues with paint flaking, screws threading, and a very important test which I'm going to include in all my case reviews from now on, the feet at the bottom of the case, it didn't scratch my desk or leave black marks all over my table when I was building with it. I've had other cases which have done both, and well known and well recognised as cases which I've actually had to add little mounting pads at the bottom to stop it scraping my desk. So sticking with build quality, but moving on to what I didn't like about the case, and I think there was two main areas where the build quality in this case let itself down slightly. The first we've already mentioned was that very flimsy dust filter at the bottom of the case. The second area I had issues with was the right side panel. While it came off with no difficulty, getting it back on once you'd built on the case was incredibly difficult. This panel has multiple locking points along the bottom and the top, and you have to get them all in exactly right for the case to lock and close securely. The problem with this is there's very limited space for cable management at the back of this case, and I did a reasonably good job of managing the cables by my own standards, which aren't that high, and there wasn't really anything that was sticking out significantly. But what cables that were there were actually pushing the panel away, and you needed to get pressure over every single one of those locking mechanisms along the top and along the bottom. And that was very difficult to do with just two hands. I tried a whole variety of different methods with my arm, applying pressure all the way along the bottom. The problem with that is you need to pull the panel once you've got it held in place. I at one point had my head holding a corner, my hand holding another corner and pulling it along. In the end, I had to actually come and get my wife to help me close the case. Again, both these slight issues with build quality aren't going to be a big issue for most users because most people don't clean their dust filters that often. Once you've got the rear panel on, you're very unlikely to be opening it again. So it might be a bit awkward to do, but once it's on, it's actually fine. Another thing I wasn't keen on in this case, and maybe it's a feature I'm not keen on rather than being specific to this case, was the hard drive indicator LED. It was flashing away all the time. I found it quite distracting, and it really didn't give me any benefit. The other issue I had with it was there was a slight gap between the front panel and the side of the case, and although the indicator LED is on the front of the case, you could actually see it flashing away through this gap at the side. So even if you were sitting to the side of the computer, it was visible. So I think if I was building in the case again, I simply wouldn't plug in that front panel connector. So it's not really a negative, it's just if you don't want to see it, don't plug the cable in. The other area of the case I'm slightly neutral on is the cutout in the power supply shroud. So your power supply is going to be visible in this case. If you've got a high-end power supply, you're probably going to like this feature. If you've cheaped out in your power supply, having it on full display isn't going to look great. The other slight issue that some of those who've watched my video have commented on is it cuts off the text on this particular Corsair power supply. So though you can see it, you're not seeing the full model name. The reason I'm a little bit neutral is because I think there's some benefits to it. I think actually in a black and white build, having the power supply adds a little bit more to the black and white theme rather than just having this all white down the bottom. The other thing, Cooler Master have included the notches in the tempered glass panel, so they cover over the power supply and slightly obscure it. The final thing I didn't like about the case also relates to the front I/O, and that was the absence of a Type-C connector. While in this price point you're not always guaranteed to get one, the direct competitors, the Purebase 500DX comes with one as standard, and the Lanco 2 mesh gives you the option to add one in. So again, probably a slight negative when you're looking at comparing this case directly to its two main competitors. So this brings me on to, if I was building in this case again, would I do anything different? And normally when you're putting a build together, you will run into some problems, and if you were doing things again, you would do them slightly differently to avoid those problems. And I think the main thing in this case is you're going to want to plug in any cables to the top of the case before you put fans or a radiator at the top. I did anticipate some of these, and I plugged in my additional power supply cables to the CPU beforehand, but I went ahead and mounted my AIO at the top before plugging in the connectors for the fans on the AIO and the connectors for the pump power supply, and both those headers are at the top of the motherboard. With the radiator in place, I couldn't access those ports. So really important you try and plug everything into the top of the case before you put any radiators or fans at the top. The other side issue is this fan on the rear of the case. Getting the cables out the back with the radiator at the top is tricky. It's possible to do, but tricky. So I would probably recommend you actually pass the cable for this fan through the back. Maybe don't install it until you put the radiator on, and then after the radiator's on, you can go ahead and put the fan up, because I think you're going to have an easier job at the top getting the radiator in without that fan, but having the cable pass through would make things a bit easier. The other slight problem I did anticipate was that once you've got a radiator at the top, you're not going to see the cables providing additional power to the CPU. So I did use cable extensions in this build. I've used them for the graphics card and I've used them for the 24-pin connector, but I used the standard power supply cables straight into these ports on the top left-hand side of the motherboard because you weren't going to be able to see them. This meant I had a slightly easier job with cable management at the back of the case. So again, if you're planning to use cable extensions and you're using a radiator at the top, don't use the cable extensions for the additional power to the CPU. If you're just planning for fans at the top, you will slightly see the cables, so you may or may not want to use the cable extensions. The final thing I would do differently if building again, and it's got absolutely nothing to do with the case, and that is I would remember to remove the plastic stickers from the very nice new Dram that TEAMGROUP sent me out for the build. Unfortunately, I forgot to do this and only realised at the end, and it was quite a long day, and there was no way I was going back and filming the sequence again. Thankfully, so far I've only had one commenter pointing it out to me, but I'm sure there'll be more to come. Okay, so this brings me on to the thermal testing. A quick recap on how I do my thermal testing. What I will do is I will let the PC idle in Windows, no programs running in the background over a 30-minute period, and then record the lowest CPU and GPU temperatures over that time period. I'll then run an AIDA64 stability test with all the components in the system being stressed and record the maximum CPU and GPU temperatures over that 30-minute period. At both idle and under load, I'll record noise levels 30 centimeters away from the closed side panel and take the average noise over that 1 minute period. So before I come on and give you the results of the thermal testing, I want to explain some of the issues I've had doing thermal testing, in particular idle temperatures, using the new NVIDIA 3000 series GPUs. And the reason I've had these problems is these new GPUs have a zero fan mode. So the fans don't spin until the GPU actually reaches a significantly high temperature. The problem with the thermal testing with this is if you turn the PC on and it's cool, you'll get a really cool GPU temperature. If you've been running the PC for a while and the GPU's at maybe say 40 degrees, that's not high enough for the fans to spin. So your GPU will never actually come down below those 40 degrees. So the actual idle temperature of your GPU depends on the point that you start measuring at. It's going to start low and then it's going to gradually increase. And actually today when I was recording this, I thought I'll check and see what the GPU temperature is with the PC just sitting at idle, nothing running in the background. And I was up at 48 degrees C with the fans not spinning at all. So that creates one problem in what point do I record the idle temperatures. The other issue this was giving me was actually the other components in the system were running much hotter. And I was alerted to this by the chipset fan actually spinning. I'd never noticed the chipset fan spinning on this motherboard before, but I was simply setting the PC up. I was in the BIOS looking at the fan curves and I noticed the chipset fan was spinning. And this is something I've never seen before during a setup, a low intensity process in any PC. And when I touched the graphics card, it was absolutely roasting and the fans weren't spinning. So this heat is obviously going towards the other components in the system and heating them up. So the only way I can get around this and get reliable idle temperatures for you is to adjust the fan curves of the graphics card so that they do run all the time. And what I did is I enabled MSI Afterburner's stock fan profile. So at the lowest, the fans will run at 40%. And when I recorded the noise levels, there was no difference in the noise levels with the fans running at 40% or the fans not spinning at all. So this was going to allow me to get a reliable idle temperature for you, which was going to be related to the other components in the system, be it the case or the case fan orientation, rather than just the time that I had restarted the idle temperature at. Before running the AIDA64 stress test, I closed down MSI Afterburner, allowing the graphics card to go back to its stock fan curves. Okay, so moving on to the thermal testing results for this build. And a quick recap, that's a 360mm AIO at the top as exhaust using LL120 fans on the radiator, but also a single L120 fan as an exhaust at the rear of the case. We're using the stock case fans at the front as intakes. So at idle, the minimum CPU temperature was 34 degrees C, while the minimum GPU temperature was 33 degrees C. During gaming, the CPU temperature went up to 81 degrees C and the GPU up to 67 degrees C. Things were a little bit hotter with a 30-minute AIDA64 stability test, with the CPU temperature going up by a further 10 degrees to 91 degrees C and the GPU up by an additional 3 degrees C to 70 degrees C. Looking at noise levels, at idle the build had an average noise level of 35 decibels, while under load it increased to 51 decibels. So the first question I wanted to look at was how good are the included case fans that Cooler Master supply. So what I did was I left the rest of the build the same, but just replaced the 3 intake fans at the front with Corsair LL120 fans. So looking at the thermal testing results, at idle the CPU actually idled 2 degrees hotter with the Corsair LL120 fans. There was no difference to the CPU temperatures under load, and the GPU temperatures were unchanged both at idle and under load. The Corsair fans were actually louder than the standard stock case fans, 2 decibels at idle and 1 decibel under load. So this test tells us that the fans the Cooler Master include in this case are of fairly high quality. They do outperform the LL120 fans, and when you consider a triple pack of LL120 fans is only going to cost you very slightly less than this whole case costs, there's absolutely no reason to replace the front case fans on this case. They do a great job at low noise levels. The next thing I want to look at was, should you mount your AIO at the top as an exhaust or at the front as an intake? So to test this, I simply moved the radiator and included fans to the front as an intake, and then moved the stock case fans to the top as an exhaust, leaving the single L120 fan at the rear of the case as an exhaust. At idle, the minimum CPU temperature was actually 1 degree hotter with this configuration, with the AIO as a front intake, while there was no difference to the idle GPU temperatures. Looking at the 30-minute AIDA64 stability test, CPU temperatures came down by 4 degrees, but GPU temperatures increased by 2 degrees, and there was no difference to the noise levels both at idle and under load. If you look at the results just on paper, your conclusion would be put the radiator at the front as an intake, because your CPU temperatures are going to come down more than your GPU temperatures are going to come up. But there's 2 other reasons why you might not want to do this. The first is, in this case, a 360mm radiator is only going to fit at the front in a tubes up position. I don't have a problem with this. In this particular build, it didn't result in any additional noise level, but there is a potential for that to cause noise. And you can check out Gamer's Nexus video on this. The bigger issue for me was the aesthetics. I think the radiator at the front did just not look anywhere near as good as having it at the top in this particular case. I'll put some footage up on the screen and you can make your own mind up on this. I think having the fans at the top with the light showing through the top didn't look as well. Looking from the inside, being able to see the radiator itself rather than the RGB fans did not look as well. So my recommendations for building in this case would be to leave the radiator at the top, because it's going to look so much better and there's very minimal difference to the temperatures. So you're probably wondering, how does this case compare to some of the other cases that I've tested? And the big problem with this is, because I'm using different hardware, it's very difficult to give a direct comparison between this case and the other cases. What I'll do is I'll put some slides up on the screen. I've only used the CPU in one other build, and that was the Cylon Base 802. Again, the hardware was different, so I'll let you make your own mind up on that. And then the big question is, how does this case compare to the Purebase 500DX and the LAN-cooled 2? So again, I'll put a configuration up where things were fairly similar between the cases. So again, have a look at that and make your own mind up, but you can't draw any firm conclusions for it. So you may ask them, why don't I, like others do, use a standard thermal testing setup for every build? Problem is, because moving forward in 3 years' time, that's going to look absolutely terrible. Why am I testing the case with parts that were from 3 years ago? The other side to that is thermal testing takes a long time to do. Every configuration I take takes over an hour to do, plus any time it takes to move the components about. So you're talking easily an hour and a half for every configuration. Problem is that I focus mostly on build videos rather than case reviews and thermal testing. So if I was to make my build video, people are going to want to know how that performs and how the various configurations change in that build video, rather than how things change with a standard set of parts that aren't related to that. So I'm going to end up having to run 2 lots of thermal testing, and it's going to take too much time. What's going to happen as the year goes on and I make more builds with the same components, you're going to have a better feel for how the cases perform. So hopefully that makes sense. Okay, so now we've reached the point in the review where I need to tell you, should you go out and buy this case? And importantly, with this particular case, should you buy this case over the Purebase 500DX or the LAN-cooled 2 mesh? And I think the answer to that is it depends on what is the most important thing to you. The cases are all very similarly priced. I think if looks are the most important thing to you, I think this case takes the win in that area. And again, that's very subjective and that may just be my opinion. There's others who are going to think the other cases look better. If noise is the most important thing to you, the Purebase 500DX is by far the clear winner. The other 2 cases can't touch it in noise levels, and it also takes up a smaller footprint on your desk. So if that's important to you, that's a reason to go for it. If features of the case are the most important thing to you, the LAN-cooled 2 mesh is the case to go for. If you look at the back of that case, you've got a tempered glass panel that swings out. You've got metal cable covers covering all the panels at the back of the case. You've got a controller button built into the case, so you're not going to have to sacrifice your reset button. And again, there's all the accessories that Lee make specifically for that case. So there's the vertical GPU mount, the addressable RGB strip. You can add the USB-C connector to it. The Purebase 500DX comes with USB-C as standard. So I think it depends, when you weigh everything up, what is the most important thing to you. But yes, I can thoroughly recommend this case, particularly for its looks, and it has a lot of the features that you're going to want from in a case at this price point. So hopefully that's been useful to you. If you're thinking of building in this case, it's going to give you some pointers for how to do that. And as well, it's hopefully help you make your mind up about whether you should go for this case. Like I say, I've done full reviews and builds in the Purebase 500DX and the LAN-cooled 2, so if you're trying to decide between them, you're probably going to want to check those out as well. So if you've enjoyed the video, please give it a thumbs up. If you're not subscribed to the channel, please go ahead and click that subscribe button, and please go ahead and check out the other videos that I've made. Thanks for watching.